What if Earth had a heartbeat? Not a gentle, life-giving rhythm, but a violent, powerful pulse thrumming with unimaginable energy. A planetary drumbeat, counting out moments of both catastrophic destruction and breathtaking creation. This heartbeat follows a very specific path. A colossal 40,000-kilometer horseshoe etched around the vast Pacific Ocean. They call it the Ring of Fire. It's not just a name, it's a stark reality. This is the planet's most active and volatile region. A seismic battleground where the very ground beneath our feet is in constant motion. Here, massive tectonic plates, the fractured pieces of Earth's crust, grind against each other, collide and dramatically plunge one beneath the other in a process called subduction. This colossal struggle is the engine that powers the Ring of Fire, making it the undisputed home to over 75% of the world's active volcanoes, and the trigger for a staggering 90% of its earthquakes. The scale of this power is almost beyond comprehension. It's the force that blew the island of Krakatoa apart, creating a sound heard thousands of kilometers away. It's the energy that unleashed the devastating 2011 Tohoku earthquake and tsunami in Japan. But this ring is also a paradox. For millennia, its volcanic soil has created some of the most fertile lands on Earth, drawing civilizations to its shores. Today, more than 500 million people live in its shadow, in sprawling megacities like Tokyo, Jakarta, and Los Angeles, all perched on the edge of geological uncertainty. So why here? What are the intricate mechanics driving this planetary machine? What is it like to build a life on land that can awaken at any moment? And what secrets is it still hiding in the crushing darkness beneath the waves, in the deepest ocean trenches where life thrives against all odds? We are on the cusp of understanding this system like never before. Join me as we embark on a journey to the front lines of our planet's most formidable force. We will explore the science, witness the power, and meet the people who have learned to coexist with the Earth's fiery breath. Stay with me. By the end, you'll be able to read the planet. Circling the vast Pacific Ocean is a belt of geological fury. It's a place where the Earth is tearing itself apart and simultaneously building anew. We call it the Ring of Fire, but this name, coined for its fiery volcanic peaks, belies a more complex and powerful truth. The Ring of Fire isn't a single simple crack in the Earth's crust. It's a colossal network of tectonic mayhem, a 40,000-kilometer-long horseshoe of deep-sea trenches, volcanic island arcs, towering mountain chains, and hundreds upon hundreds of active volcanoes that fringe the Pacific Basin. This is the planet's most dynamic frontier, responsible for about 90% of all earthquakes and home to 3/4 of the world's volcanoes. To understand this immense power, we have to look deep beneath the waves, at the engine that drives it all, the slow, unstoppable dance of plate tectonics. The Earth's surface is broken into massive, rigid slabs called tectonic plates. These plates are in constant, gradual motion, moving at about the same speed your fingernails grow. Around the Pacific, a fundamental drama unfolds. Huge, dense plates born of cooled lava on the ocean floor are on a collision course with the lighter, more buoyant continental plates that carry the lands we live on. When they meet, something has to give. The heavier oceanic plate is forced to bend and dive downwards into the Earth's hot mantle in a process called subduction. This is the master architect of the Ring of Fire. As this oceanic slab descends, it doesn't go quietly. It scrapes and grinds against the overlying plate, building up incredible stress that is later released as powerful earthquakes. But the most transformative part of this process happens deeper down. The descending ocean plate carries a hidden ingredient, water, locked away within its very minerals. As the plate plunges into the mantle, immense heat and pressure squeeze this water out. This water then rises into the searingly hot mantle rock above it, and here it works like a chemical catalyst. It dramatically lowers the mantle's melting point, a process known as flux melting. Solid rock begins to melt, creating buoyant blobs of magma. This molten rock, or magma, is less dense than the solid rock around it, so it begins a slow, determined ascent toward the surface. It pools in vast underground chambers, and when the pressure becomes too great, it erupts, building the iconic cone-shaped volcanoes that define the Ring of Fire. This direct link between subduction and melting explains the geography of the ring. The volcanoes don't just appear randomly, they form distinct lines or arcs, sitting a predictable distance inland from the deep ocean trenches where the plates first meet. However, not all plate boundaries here are subduction zones. In places like California, along the famous San Andreas Fault, The Pacific Plate and the North American Plate are sliding past each other. This transform boundary generates massive earthquakes as the plates snag and release. But because there's no subducting slab releasing water to trigger melting, you get far fewer volcanoes. It's the act of one plate diving beneath another that truly lights the ring of fire. And this engine operates on a global scale. In South America, the Nazca Plate dives under the South American Plate, thrusting up the Andes, the world's longest continental mountain range. In the Pacific Northwest of the United States, the subduction of the Juan de Fuca Plate has built the Cascade volcanoes, a chain of sleeping giants like Mount Rainier and Mount St. Helens. Further west, where the Pacific Plate subducts beneath other oceanic plates, it creates spectacular island arcs like Japan and Indonesia, some of the most volcanically active and densely populated regions on Earth. Different countries, different cultures, but all are shaped by the very same geological engine. Subduction draws the lines. Magma writes the story. Living on the Ring of Fire means living with a profound duality of creation and destruction. The hazards are immense and ever-present. The same tectonic forces that build mountains trigger the most powerful earthquakes on the planet. Megathrust quakes that can rupture the seafloor and unleash devastating tsunamis. Volcanic eruptions pose a complex web of threats: fast-moving pyroclastic flows of superheated gas and ash, suffocating ash fall that can collapse buildings and disrupt global air travel, and volcanic mud flows called lahars that can sweep away entire communities. Yet for all its danger, the Ring of Fire is also a giver of life and resources. For millennia, people have been drawn to its slopes. Volcanic ash weathers into incredibly fertile soils, rich in minerals that support vibrant agriculture. The same magmatic systems that fuel eruptions also concentrate vast deposits of precious metals like gold, silver, and copper, driving economies and shaping human history. And in the modern era, we've learned to tap directly into the Earth's heat. The shallow magma chambers provide a powerful source for geothermal energy, a clean, renewable power that turns the planet's inner fire into electricity. This is the paradox of the Ring of Fire, a place of terrifying risk and incredible reward, where civilizations have learned to thrive on the edge of disaster. It is a story of science, survival, and our complex relationship with the dynamic planet beneath our feet. Living on the edge of the Ring of Fire means living with a constant, low-level hum of uncertainty. The ground beneath your feet is not static. It is a living, breathing system. So how do we listen to its whispers? How do we anticipate its roars? The answer lies in a sophisticated network of planetary senses, an array of technologies that act as our eyes and ears on the ground and even from space. Our first line of defense is listening for the Earth's heartbeat. We use instruments called seismometers, devices so sensitive they can detect vibrations far beyond human perception. We're not just waiting for the big one. Scientists are listening for very specific sounds, the subtle, continuous vibration known as harmonic tremor, which often signals that magma is moving through the volcano's plumbing. They listen for deep, long-period earthquakes, low-frequency events that can indicate the pressurization of a magma chamber miles below. Each tremor is a word in a language we are slowly learning to translate. While seismometers listen, a constellation of global positioning system or GPS stations watch for the silent swelling of the ground. Anchored deep into the bedrock, these stations constantly receive signals from satellites. By triangulating their positions with millimeter-level accuracy, scientists can detect when the ground begins to bulge upwards, pushed from below by an inflating magma chamber. A few millimeters of uplift might not sound like much, but spread over kilometers, it represents an enormous volume of molten rock forcing its way towards the surface. It's a slow, silent inhale before a potential roar. To get an even broader view, we look from orbit. Using a technique called interferometric synthetic aperture radar, or INSAR, satellites bounce radar signals off the Earth's surface. By comparing two images taken at different times, they can create a map of ground deformation. These maps often look like psychedelic, rainbow-colored contours laid over the landscape. Each colored fringe represents a specific amount of movement, a few centimeters of uplift or subsidence. This allows us to see the big picture, to witness the entire volcanic edifice breathing. But the ground is only part of the story. We also need to sniff the volcano's breath. As magma rises, it releases dissolved gases like sulfur dioxide. A sudden spike in these emissions is a classic warning sign that fresh magma is nearing the surface. We can also see the unseen heat. Thermal cameras mounted on drones or satellites can detect minute changes in surface temperature, revealing new hotspots where volcanic gases are escaping. A volcano heating up from the inside often betrays itself with a subtle thermal glow. No single instrument tells the whole story. The true power of modern volcanology lies in combining these data streams. A swarm of deep earthquakes, coupled with ground inflation, a spike in gas, and a new hotspot, together these signals paint a compelling and urgent picture. This multi-pronged approach is what gives us early warnings. These warnings are not perfect predictions. They are probabilities, communicated through a clear alert system. This was put to the ultimate test in 1991 at Mount Pinatubo in the Philippines. After centuries of slumber, the volcano began to stir. A team of scientists tracked the escalating signals and made the difficult call to recommend a mass evacuation. Over 60,000 people were moved from the danger zones. When Pinatubo finally unleashed one of the 20th century's largest eruptions, it was a cataclysm. But thanks to the science, it was a catastrophe with tens of thousands of survivors. This is why communities from Japan to Chile, from Indonesia to the US West Coast, have developed sophisticated preparedness plans. They have marked evacuation routes, built reinforced schools and hospitals, and run regular drills. They know that living on the Ring of Fire requires a partnership between scientific monitoring and community readiness. And yet, for all our focus on the present, it's crucial to remember that the Ring of Fire itself is just a fleeting moment in geological time. The Pacific Plate continues its slow-motion dive, but one day, hundreds of millions of years from now, the Pacific Ocean will close entirely. The continents will reorganize and new rings of fire will be forged around new oceans. Today's fiery rim is just one spectacular chapter in a planetary novel that is still being written. So the next time you hear about a distant earthquake or see a volcanic plume on the news, remember the intricate web of science and human resilience behind the headlines. It's the sound of our planet breathing, a reminder of the immense forces that shape our world and the ingenuity we use to understand them. What part of this incredible ring should we explore next? Join us as we journey into the heart of the fire. Subscribe for the next chapter.